In this lesson, we are going to discuss decomposition or analysis reactions. At the end of this video lesson, you should be able to define decomposition or analysis reactions and predict the reactants or products of decomposition reactions. Decomposition reactions involve a single compound that is broken down into two or more compounds or elements. It follows the reaction AB decomposing into products A plus B. Compound AB is much more complex compared to substances A and B, which may be a single element or a less complex compound. Decomposition reactions are usually driven by heat or electricity that allows the breakdown of the reactant. In this video lesson, we're going to discuss 4 decomposition reactions. The first one is the decomposition of hydrates. A hydrate is any compound that has absorbed water molecules from its environment and included them in its structure. Its decomposition involves the separation of the salt compound and water. For the first example, we have the decomposition of sodium chloride octahydrate. The salt product of this decomposition reaction is sodium chloride. It becomes separated from the water component, particularly 8 molecules of it. This reaction is already balanced since the hydrate components are just separated. For the next example, we have the decomposition of magnesium sulfate heptahydrate. The salt component of this hydrate is magnesium sulfate, and the other product is water, particularly 7 moles of water. Again, this reaction is already balanced. Now, let us discuss predicting products of decomposition reactions involving metal chlorates. Metal chlorates are ionic compounds consisting of a metal cation and an anion chlorate. A metal chlorate will decompose into metal chloride and oxygen. Metal chlorides, most especially those with type 2 cations, are written based on the metal ion used in the chlorate. Oxygen, on the other hand, is written as O2 because it is a diatomic element. For the first example, we have the decomposition of potassium chlorate. The first step in identifying the metal chloride product of this reaction is to identify the metal and its charge. Potassium belongs to group 1A, and chlorine belongs to group 7A, thus forming the chloride ion with a negative 1 charge. Doing a crisscross of these charges, we have KCl or potassium chloride. The constant product for this reaction is the diatomic oxygen molecule. We still need to balance this reaction. Thus, the complete reaction is 2 moles of potassium chlorate decomposes into 2 moles of potassium chloride and 3 moles of oxygen. For the second example, we have the decomposition of magnesium chlorate. For its metal chloride product, we need to identify the metal and its charge. Since magnesium is a type 1 cation belonging to group 2A, its charge is positive 2. It will be forming an ionic compound with chloride ion. Thus, we have MgCl2 or magnesium chloride. The other product is the diatomic oxygen molecule. Since this reaction is not yet balanced, we're going to put 3 as a coefficient of oxygen. Thus, the complete balanced reaction is 1 mole of magnesium chlorate will decompose into 1 mole of magnesium chloride and 3 moles of oxygen. For the third decomposition reaction, we have the decomposition of metal oxides. Metal oxides are products of metal cations and the oxide ion with a charge of negative 2. The two products of these reactions are a free metal and the diatomic oxygen molecule. In this decomposition reaction, we do not write any charge for the metal in the product since it will be a free element. For the first example, we have the decomposition of lithium oxide. The metal in this reaction is lithium, thus it is the first product. The second product is a constant product and this is the diatomic oxygen. To balance this reaction, we have 2 moles of lithium oxide will decompose into 4 moles of free lithium and 1 mole of the diatomic oxygen molecule. For the next example, we have the decomposition of iron 2 oxide. Regardless of what ion the iron metal will form, it will be the free iron metal in the product side. The other reactant will be the diatomic oxygen. Balancing the reaction, we have 2 moles of iron 2 oxide decomposing into 2 moles of iron and 1 mole of the diatomic oxygen molecule. For the last decomposition reaction, we have the decomposition of metal carbonates. A metal, being a cation, forms a compound with a carbonate ion, an oxygen ion of carbon with 3 oxygen molecules with a charge of -2. This will form 2 products. The first one is a metal oxide. The charge of the metal will be the subscript of oxygen. Oxygen, on the other hand, has a charge of -2. Thus, 2 will be the subscript of the metal in the compound. The second product is carbon dioxide. This is constant for all metal carbonate decomposition reactions. Let us look at some examples for the decomposition of metal carbonates. For the first example, we have the decomposition of potassium carbonate. The first step in determining the metal oxide product is to identify the metal and its charge. Since potassium is the metal in potassium carbonate, it is also the metal in the oxide. Potassium has a charge of +1, and oxygen, as an anion, has a charge of -2. Thus, our metal oxide product is potassium oxide or K2O. The other product is a constant product for metal carbonate decomposition reactions. This is carbon dioxide. This reaction is already balanced. Thus, the decomposition of 1 mole of potassium carbonate will yield 1 mole of potassium oxide and 1 mole of carbon dioxide. For the last example, we have the decomposition of calcium carbonate. The metal oxide product of this decomposition reaction will be derived by identifying the metal and its charge from the metal carbonate reactant. This is calcium. It has a charge of +2. It will form an oxide compound with oxygen that has a charge of -2. Thus, we have CaO or calcium oxide. The other product is carbon dioxide. This reaction is already balanced. Thus, 1 mole of calcium carbonate decomposes into 1 mole of calcium oxide and 1 mole of carbon dioxide. Now that we have discussed some decomposition reactions, let us now review the following key points. Decomposition reactions involve the breakdown of a single reactant into 2 or more products. Hydrates will decompose into salt plus water. Metal chlorates will decompose into metal chloride and oxygen. Metal oxides will decompose into a free metal and oxygen. And lastly, metal carbonates will decompose into metal oxide and carbon dioxide. And this ends our discussion on decomposition or analysis reactions.